Hey, look at that. The lighting's better. Did you know that if you film in the dark, it's bad? All right. So I'll keep going. So let's see. This one says the graph of the function f shown below consists of 3 line segments and a semicircle. If we didn't know this was a semicircle, we'd have to use some form of estimation. There'd be a lot that we couldn't do. But since we know it's a semicircle, then we have a lot we can work with. Also, if we didn't know these were line segments, technically, like in a question on the front side, there's some things that we wouldn't be able to do. First and foremost, I need to correct a typo. This really should say g of x is equal to -2 to x of f of t dt. If it doesn't say that, then it muddies up what's actually happening. So it says find g of 1. So I'm going to write up here to kind of keep it in line with the picture. So g of 1, well, if we plug 1 in for x, then we get -2 to 1 of f of t dt. And remember that the integral from -2 to 1, that's just the area from -2 to 1 of this. So I just got to go over here and go ba-da-da-da-da-da-da. I got to find the area, all the way up to 1. And I broke it up like this personally because I see a triangle here, the triangle with a base of 1 and a height of 4. So that's 1/2 times 1 times 4, which is 2. So the area of this piece is 2. The area of this, we'll get back to that shape. The area of the, we'll get back to that shape. Let's do the trapezoid first. The trapezoid looks like this. Bop, 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 right? We got a base here. We got a base here. We got the height. Well, the height is 1. Base 1, well, that's 4. Base 2, that's 3. Remember the area of a trapezoid, and you have to know area of a trapezoid. You have to have that memorized. 3-dimensional stuff, no, but you need this one. The College Board will expect that you know this. So we just add the bases together, divide it by 2, so I get 7/2, or 3.5. So this is 3.5. Now we got to figure out this mess. So, okay. This on its own is going to be tricky, but if I think about it as there is a rectangle and I am subtracting out a quarter of a circle, that will be a lot simpler. So my whole rectangle is a 1/3, so that's 3, and the whole circle has a radius of 1, so that's the area, that's pi r squared, which is pi times, is that loud for you? That's really loud for me. It's the area is pi r squared, so the area is pi. But if we just want a quarter of that, we divide it by 4. So our area there is pi over 4. So we've got a 2, we've got a 3.5, and we've got a 3 take away a pi over 4. 3 subtract pi over 4. So if I add all that up, I get, so g of 1 is equal to 2 plus 3.5 plus 3 subtract pi over 4. So I'll just clean that up. G of 1 would be equal to, let's see, 6, 8, 8.5, 8.5 minus pi over 4. If you'd rather write that as a fraction, you could say that's, let's see, 8 would be 16 and 1 extra half, so 17/2 minus pi over 4. And if you want to be annoying, you can get a common denominator and get 34 minus pi all over 4. But I don't know why you'd do that, except if it's a multiple choice question and the answer was written like this, you'd need to be able to find that. So the way that we found that was we multiplied this by 2 over 2. Okay, so that's g of 1. Now we need to think about what g prime of 1 is. Well, let's find g prime first. What is g prime equal to? Well, g prime is equal to the derivative of negative 2 to x f of t dt. Wait a minute. The derivative of an integral. Oh yeah, we just plug in the bounds. So it's just f of x times 1 minus f of negative 2 times the derivative of negative 2, which is 0. So it's just equal to f of x. So g prime is equal to f of x. So g prime of 1 is equal to f of 1, which is equal to the y value when x is equal to 1. X is equal to 1, y value is 2, done. Next question says, find all the values of x on the open interval negative 2 to 4 at which g attains a relative max. Okay, g attains a relative max. That means g prime is equal to 0. At least that's our first necessary condition. Let's find any places where g prime is equal to 0. Remember from earlier that g prime is equal to f of x. So I'm really just saying, when is the y value equal to 0? And there's a couple other things that have to happen too, but we'll check for those. So let's see. The y value is equal to 0 here. The y value is also equal to 0 at 3. So one of those two could be a max. Remember, to find a max, g prime would need to change from, a max looks like this. So that means we need to change from positive to negative. The slope needs to change from positive to negative. So that means that g prime changes from positive to negative. Or the y value. The y value changes from positive to negative. So if we go back to our picture, here, the y value doesn't even change. The y value starts at 0 and then starts going up. So negative 2 is right out. But 3, the y values are positive, 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 0, negative, negative, negative. So at 3, we have a relative maximum. So if we were going to write this, we could say g attains a relative maximum at x equals 3 because g prime of 3 is equal to 0 and g prime of x, changes from positive to negative at x equals 3. And I'm sure I could have written that a little bit cleaner, a little bit quicker, but that's the basic idea. So let's keep going. All right, more questions. All right, this first one here, this is legit the same question that the first one was, just different numbers. So it says f of x is equal to, or wow, let's try words. The integral of f of x from a to b is 2a minus 3b. Okay. But we have this integral of f of x plus 3, so we just need to split it up into two integrals, from a to b, f of x dx, plus from a to b, 3 dx. This first one we know is 2a minus 3b. This one we know is 3x from a to b. So that's going to be 3b minus 3a. And then it's just a matter of combining like terms. So I got 2a's and negative 3a's, that's negative 1a's. Then I've got negative 3b's and 3b, oh, they're gone. So I got negative a for my answer. See, the graph of f is shown below. If we know this integral, and just reminding us that that's true, then what's that? Oh, big F of 4 minus big F of 1. That's the same as from 4, whoops-a-daisy, from 1 to 4 of little f dx. We're looking for the area from, 1 to 4. Hey, it's this. Okay. And we know that this is equal to, it tells me it's 6. 6. Woo. So my answer is not 6 because I also have these two things right here. This one and this one. See, that's 1 there. That's 2 there. This is 2. Let's see, 6 plus 2. There we go. Okay. All right. The following. Hey, just a heads up. If the video that was before this, when we were going through this question, like it was up here. It's the exact same. It's the same. It's just look at that. There's even an A in the table. It's the same. Okay. What is the integral from 1 to 3 of f of x? Let's see, from 1 to... Wait, that's the same thing as saying big F of 3 minus big F of 1. Big F of 3 is 8. Big F of 1 is 3. The answer is 5. All right. Cannot be determined. LOL. Totally can. Look at me LOLing. All right. Wait, why am I scrolling up? I shouldn't scroll up yet because we're going to need this. So just like the last question, if the area under the curve f of x on the interval 0 to 2, so the integral from 0 to 2 is equal to the area under the curve from 2 to 3. It's almost like these questions were ripped off of a worksheet and then I went back and changed the numbers to provide more questions like them. Oh wait, that's what I did. All right, so 0 to 2. I guess that means that I'm doing fair use right now. I don't remember where these questions came from. Hashtag don't sue me. So we know that this first one is big F of 2. Actually, if this is your work and you have a problem with it, just let me know and I will remove it from the internet forever. So we're just able to set that up. And we know big F of 2 is A. We know big F of 0 is 4. We also know big F of 3 is 8. Big F of 2 is still A. Why did I put equals? I should have written subtract. So we'll add the 8's together, get 2A minus 4 is equal to 8. So then 2A is equal to 12 and A is equal to 6. All right. Oh, there's my answer. Cool. All right. Strong recommendation I recommend you actually do the problem and then look at your answers if you know how to do the problem. A lot of times there's intentionally misleading stuff in here. So, all right, 5. We want to compute d dx of an integral. We want to take the derivative of an integral. Oh yeah, so we just plug the bounds in and make sure chain rule happens. So I'll drop the x squared in. Square root of x squared times 2x, and then square root of x and times 1. Let's see. Do I see my answer here? Nope, I don't see any of these as my answer. Let me keep going. Well, the square root of x squared is x, so that's 2x times x. 2x squared.
Good morning, Dickinson.
There we are. And I'm going to stop.